All right, so let's dive deep and look at data structures in Python specifically. Okay, let's understand what exactly is data structures and how we can use it in programming and how we can manipulate this structure because these structures are definitely meant to be manipulated. Okay, in certain situations, right? So let's just go straight to our VS Code and then whatever we need to talk about or theory, we will we'll put it down there on in the VS Code, right? Okay, so let's go. So I already have my VS Code here open, and I want to believe that you guys are seeing my VS Code right now. Yeah, please, I want to believe that we are seeing my VS Code. Yeah,
Yes, I can see it. Resume it a
how you
little.
guys seeing? Okay, so I think it could be if let me just talk about my network a little bit. That's why it's if this network is behaving a little bit. All right, so I believe that we are that everything is going is moving smoothly now. Yeah, you guys can see the VS Code now. Yeah, properly. You guys can see what I'm typing. Okay, please confirm that. I want to be sure that we are good to go.
Yeah, we can see.
Or you guys can see that instruction. All right. Okay, so let's proceed. Okay, let's proceed. So what exactly is data structures? What are data structures in programming? What are data structures in programming? What are data structures in programming? All right, so let me put it in the most simplest form that all of us would basically understand. Okay, so data structures are basically it's a way where values or data can be arranged for easy manipulation and accessibility, right? Okay, let's just use manipulation, okay? So that's basically what data structure is. It's a way or a manner or a structure. No, I don't want to bring in structure because then the structure there already. Okay, so it's a way values can be uh, stored and retrieved for easy manipulation. Okay, manipulation. All right, so it's going to be a very simple and sweet concept. Okay, so in that is basically what data structure is, right? It's just a way where you developers can just store and retrieve information, okay, for easy manipulation, right? So what do I mean? There is before now we can only store one value to one variable. So basically, a container, one variable container only contains what one specific value, right? So we cannot have more than one in for a particular container. If need be, we can only do what switch. But with the help of these data structures, okay, we can do what we can store as many values as possible for a particular variable and what we can manipulate these values within within this structure. Are we together? Okay, so in Python we have about four types of data structures, right? So these data structures are also data types. Okay, so what do I mean? Each of these structures are also seen as data types in Python. Okay, so it's we just call them the data structure because they offer a way of storing and manipulating what data. That's just it. Okay. Do we understand up to that point, or should I re-explain that point before we dive into actual coding? Please, I want to confirm that too, that we understood that explanation.
Mr. B, please come back. I just entered. What did you say?
All right. Okay, so for the purpose of those that just joined, all right, so let me go ahead and re-explain what I just finished explaining. Okay, so for this particular class, okay, that this is for those that are just joining and probably those that uh that were lost. Okay, so let's re-explain that again. So for today's class, we are going to look at what data structures in Python. Okay, and I said about that data structures are just is just a way or a manner or a method, right, or a process of what of storing and what and retrieving or manipulating what data. That's just what data structure is. So you can compare it to your what to your structures that okay let's have let's two structures in mind. Okay, let's say we have books, right? And then we intend to store as many books as possible. But then we intend to retrieve these books when need be, probably count it, sort it, uh, remove it, give it out with a hand. Now, these books, right, can be stored in different ways, right? Now, a typical example is shelves, right? What you have in libraries. So you just stack them side by side, right? So that shelf can be seen as book structure, right? It just a means of storing books for easy accessibility or manipulation or retrieval, right? Or these books can also be stored in drawers, right? So basically, you just have a drawer where you just stack the book one on top of another, right? Now, all these are just structures, but then they have different means of accessing and manipulating what this or retrieving what these books, right? So for the drawer, what the books are stacked one after the other. So if you need to retrieve, let's say, a book under, the first book needs to keep going out like that to what till you get to a particular book that you're looking for. But then compared to a shelf, right? The book are just stacked side by side. So you can just easily, pull out and then put it back in, right? So same concept is also available in what in programming, right? So before now, I said that before now we basically just do what just store one value to a one container or to a one variable, right? So there was no means of storing more than one without having multiple variables, okay? But with the data structures, it gives us a manner or a way or a process of storing more than one value to a variable, and each of them have their method or have their means of manipulating this data stored within them. Okay, that's basically what data structure is, both in programming and in other languages, right? Both in programming and in Python and other programming languages. They're just what means of storing data and what are manipulating them. Are we together? Do we understand? Do we understand? Please let someone confirm that we understand so we can proceed.
Yes, sir. Yes, sir.
All right, so let's go ahead and let's proceed. Okay, so now let's scope it down towards to Python programming. Now in Python programming we have three data types. Okay, sorry, four data types that is considered as what are data structure. So please remember these are also data types. So the same way you view int, string, float, and boolean and so on and so forth. These are also what data types, but then they are specifically called data structure due to what due to the ability that they possess, where you can do what where you can store more than one, two, three, four values, and what this and then each of them have their means of manipulating the values within them. Okay, so one of them is called the list, right? The other one is called what a tuple, and the other one is called a dictionary, right? Dictionary. And the other one we have sets. So those are the four data types or that is also considered as what are data structures in Python. And then we are going to see how each of them behave or how each of them store things and manipulate the things that they store within themselves. Okay. So that is basically what we look at in this particular class. Okay. And let's say within a few minutes we should be done, and that should be that for today's class, right? So today's class is not actually meant to be that long. Okay, so for this class, I'll cover the first three, the list, the tuple, the dictionary. I'll leave the sets for us to do what in our spare time. You can look up sets. Please, these data structures are very important, right? because we can use them. We already use them in our previous task. Most of us just use them. Right? But I hope and believe that after this class, we should be able to go back and look at that our code and answer the reason why we use them. Okay. So let's do what let's dive in. Okay, let's dive in. So let's start with lists. The list data type list data type. You can call it data type. You can also call it data structure. Right. So because both of the list itself fall within the both category. List is also a data type. List is also considered a data structure. Okay, so the list data type or data structure, right? It's what exactly or how do they behave or are they created or how do they do things? What happens within a list? So a list is basically a collection of a list is basically what a collection of values, okay, separated, okay, separated by commas, and what enclosed with a square bracket, with a square bracket. So with a square bracket. So this definition you may not actually see it online. So this one just come out at the top of my head because that's basically what a list is, right? It's just basically what a collection of of values, okay? And these values are what are separated by commas, and then all of them are then what are then enclosed within a square bracket. That is basically what a list is. Okay, so I can further also say that that these values can be of any data types in Python. So let me just bring this down. Okay, so these values can be of any data types in Python, and the order of these values matters. Okay, the order of this value they matter. So it simply means that the order in which these values are being inserted, right, actually matter because you somehow need to actually know where a particular value sits and where a particular value does not actually do what sits. So that is basically what a list is. That's basically what a list is theoretically. Now let's do what let's dive into create or making this a program. Okay, so let's see how this can be created what in program. So from that definition, we can just simply say that anything within a square bracket is considered what a list. So by that definition, this is what a valid list. This what I just did here is a valid list. So if I assign this to a variable, let's say I assign this to a variable called L. Right now, if you guys still remember that our built-in type function, right? If I should say what is the type of, if I say print the type of the type of L, right? So this will show us what that type that structure belongs to, right? So if I should run this now, we should have that belongs to what to the class of what of lists. So you can say that is a valid list because that is basically what a list is. Anything, right? Any values separated by comma enclosed in square bracket. So these values they are optional, right? So a list can be empty. A list can also be filled, right? So it's up to you. So this is a valid list, right? So this is a valid list. It's just that this particular list what is an empty list, a list with no values, right? Now let's go ahead and let's create another list. This time around a list of fruits. Okay, so I can call this fruits, right? Fruits. And then here's this one here. I'll just simply just call this and then within this structure, I'll do what I'll put my multiple value of what of fruit. So in this case, I can have what I can have my apple, I can have my pineapple, okay, pineapple, okay, so pineapple. All right, so we are probably wondering, so why do we need to put quotes in this one? So remember, these values are what must be a valid um data types in what in Python. So because these are not numerical values, they are strings, so as such they need to go in quotes. Okay, so that's basically that's and then I can have another value. Maybe I can call this mango. Okay, and then I can have another one. Maybe I can call this well, I can't think of another. Okay, orange. let's let's go ahead and give this. All right. Okay. All right. All right. So that is basically what that is basically another valid what list creation. Okay. So the other one was a list with no value. And this second one what is a list with what with values. So in this case, it's basically what a list of fruits. Okay. Of course, your list can be filled with anything. So you can have a list that is filled with mixed data type. Okay, so in Python, your list can contain any of the data types that we have in Python. So unlike other programming languages where your list must be of the same type. So if you declare your list to be a list of integers, it means that the content of that list must be what must be integer. But in Python, that is not the case, right? Here in Python, that is not the case, right? Your list can actually be of different data types and there is no problem. So let's look at a typical example of a mixed list. So I can have a mixed underscore list, underscore list. Okay, and this will be I can have a 1, can have 2, can have 10.7, I can have 5.5, I can have a Boolean value of true, can have a Boolean value of false, can have sorry, this is it's capital F. I can have what should I word? I can have a string of hello, I can have another string of human. Okay, I can also have a list of a list. So I can also have remember this list I also did data types in Python. Okay, so I can have a list of let's say just random things like hi and there and 100. Okay. So that's basically a typical example of what of a mixed list. And there's nothing wrong with this list, right? These lists are all valid lists. All these are all what are all valid lists. So it's your choice as a developer to do what to know the possible values that you want to insert into your list. So that the content of that list is strictly up to you as the developer. So it's your choice to know what goes in there and what doesn't go in there. Okay. So now with that, you can see that we can now have multiple value, but within what a single structure attached to one variable. Now, before now, we can just be having multiple variables for each of those value. But with data structure, we can do what we can have these multiple values, right? And all considered as one single structure. Okay. And then we can do what we can simply just print it out. So there's no special function of printing out a data structure. You still use your you still use your normal print function. And here I can just print I can print fruit if I want. I can print my fruit. And then I can also print my mixed list, okay? My mixed list, and I can also print my empty list, okay? Which is what the L. So all of them are all valid lists, right? So if I should execute this now, you can see that we have them all displayed here perfectly well, right? So that's basically how you create a list. That's basically how a list is being created, or what a list is, right? It's basically it's basically a collection of values separated by commas enclosed within what a square bracket. So anytime you see any structure that's been enclosed with square bracket, just know that is what a list. Okay, a list data type, also a list data structure. Question before we proceed. Question. All right, so the silence be no question that we are following just fine. All right, so let's move into the manipulation of what of these structures. Now remember, each of these structures have a means of dealing with the data within them, right? Because so far, if we try to print this list, it will just print the entire structure, right? And in most cases, we don't want the entire structure. In most cases, we want a specific item or a specific value within that structure, right? So us printing this entire structure is similar to what to someone going to a library and then carry the entire shelf, right? Which in reality you don't try that, right? You don't try that. You don't go into the library and carry the entire shelf. So you just go and carry one single book or two or three or four, but not the entire library. Okay, you don't just go and carry the entire library, right? So So how do we now do what? How do we now manipulate these structures? Okay, so now let's look at the manipulation part of what of this structure. Okay, so how do we do what? How do we manipulate list manipulation? Let's look at list manipulation. Okay, list manipulation. All right, so every manipulation fall under this keyword called crude. Every manipulation that you ever do in this life will fall under any of those category called CRUD. So CRUD is an acronym that stands for what? Create, retrieve, update, delete. That is the four specific data manipulation that exists. Okay, so is that you're creating something, or you're retrieving something, or you're updating something that already existed, or you're deleting something that already existed. Right? I cannot think of any other manipulation apart from those four categories. So every manipulation in this life will do what will fall within the boundary of what of this acronym called CRUD. Create, retrieve, update, and what and delete. So let me just quickly just put that there. Create. So create. Okay. We have the retrieve. And then we have sorry, it's retrieve. Then we have the update, and then we have the what? The delete. All right. Okay, so let's go ahead and let's see how this is done specifically in list structures. Okay, so before now we basically been what we've been just retrieving the entire structure. Basically, we've been carrying the entire library, okay, and then just showing it to the user, which in most cases should not be so. Which in most cases should not be so, right? Which in most cases should not be so. All right, so let's look at first of all, let's start with the create. Let's look at how we can add item to a list, right? Okay, let's start with retrieve, right? Since we already have a list that already existed, let's try and retrieve what an item from that list. Then after that, we look at how we can add, update, and so on and so forth. Okay, so let's see the retrieve. How do you retrieve an item from a list structure? It's pretty simple. You do what? You reference the list name, uh, the list name, the list name, and then in square brackets, the index of that item, index of item or value, anyone that we use, item or value, whichever one. Okay, so that's basically how you retrieve an item from a list. Okay, so you'll be wondering, all right, since we already know this list name, which in this case is what mixed fruits and sorry mixed list of fruits or L, right? What is now the index of the value? So the index of the value is basically where is that value sitting in that structure. So every item in a list structure starts from what? Start from index 0. So what do I mean? I mean that this item called Apple is sitting on index 0. That is the beginning part of this list. That is index 0, right? And then the next item that sits after that is what is index 1. And the next one is what is index 2. And this is what index 3. Right? So that's basically how indexing works in list structure. Every item begins at index 0 up to where to the last item in that particular structure. So 1 here is what is sitting on index 0. 2 here is what is on index 1. Here index 2, 3, 4, 5, 6, 7. What index is this? Anybody want to give attempt?
Eight, eight,
Index 8, 9, 10.
8, 9, 10. Okay, so
8,
I've
9,
hit
and
8.
10.
Okay,
index
okay,
eight,
so
index eight.
okay, I've hit index 8. I've also hit index 8, 9, 10. All right. Okay, so that is a fantastic attempt, right? Okay. So this man here, right? This man that is sitting here, of course, is sitting on index 8, right? But that whole structure is not what is seen as one single value within this whole structure. So it means that high, there, and 100, all of them are all considered as one value within this structure, which means that all of them is sitting on index 8. But then if you now dive deep, because these other value now is also another structure within that structure, right? So it simply means that what at this point, hi is sitting on index, oh, sorry, on index 8, but then index 0 of that inner structure. I don't know if I'm making sense, right? Same thing with this other guy here. There is nothing on what on index 1, but on index 8 of the of the entire structure. Does that make sense? Or am I confusing? Am I causing confusion here? Please, I want to convey that we understand how that logic works, all right? That this man here sits on index 8, right? While this man here sits on index 0. And this man sits on index 1. But the whole of them, the whole structure sits on index 8. Does that make sense?
Yes, sir. Yes,
Does,
sir.
all right. Fantastic. So let's proceed. Okay, let's proceed. Okay, so that's basically how indexing works. That's basically how indexing works in list, right? So every item within a list, okay, starts from 0 all the way to the last item. Okay, and that is how you retrieve data within what a list. Okay, so let's go ahead and let's do that. So here I can just simply say I can just simply just say print. Okay. Print fruit. Remember you reference the list name and then in square brackets the index of the item. So let's assume that I want to retrieve this man, pineapple. So that means I'll simply just say index 1. Okay, and then I can execute this. And instead of bringing the entire library, I simply just get a single value within that structure, which in this case is what is pineapple. Okay. That is basically how retrieving of item works. So Kenneth, your hand is up. You have a question? Kenneth, your hand is up. Is Kenneth still
This
with
list.
us?
Yeah, I'm speaking. Can you hear
All
me?
right. Yes, I can hear you now.
Okay, I said the list is still the same thing as an array.
Yes, in other programming language, you will hear of array. Yes, yes, it's the same thing with that, with those programming language. But in Python, we just have list, we don't have array. So that array that you know is the same thing as list here in Python. So both of them is the same, array and list. But in Python, it's called list. Okay.
Okay, thank you, sir.
All right. All right. So let's proceed. Is there any other question before we proceed? Any other question? Any other question? Any other question? All right, no other question. Let's go ahead and let's proceed. All right, so that's basically how you do what how you retrieve an item from what from a list structure, right? So you reference the list name and then what the index of that item. But there are also situations where you want to retrieve more than one item, right? You want to retrieve more than one item. So in retrieving more than one item, how do we do what? How do we accomplish this? Right? Okay. How do we accomplish it? Because if we try to do this, right? Because I'm sure that we are already guessing. Just put comma there, and then you do what you put the other index, right? well, how do I put it? Sentimentally, that looks correct, but programmatically, that is wrong. Okay, so you don't do that because actually the first time I saw this, I did this right to retrieve more than one item, and it was wrong. Right, so please don't do that. Right, so to retrieve more than one item, we do what we call slicing. So it's called slicing, right? Slicing of structure, right? Of list structure, rather. Slicing of list structure. All right, so slicing here is basically what is basically cutting a portion of your list. All right, so you can cut a portion of your structure. That's basically what slicing is. So now when you cut that portion, it helps you what it helps you do what to have more than one item at the same time. Okay, but then this other method only retrieve one item at a time. Okay, so now let's go ahead and let's see how this slicing works in and how this slicing work in list structure. So let's see how this slicing work in list structure. So to slice, it's pretty simple, right? It's pretty simple. You just you simply reference the list name again as usual. Simply reference the list name, okay, the list name, and then in square bracket you put the index and the start index, okay, the start index, and then followed by colon, and then the end index, index, the end index plus one. All right. So now what do I add plus one? Because the end index is not inclusive, right? So the end index is not always inclusive in slicing. So let's say I want to slice from index 0 to index 1, right? And now in your head, you're expecting what? Apple all the way to what? To mango. But if you just put index 0 all the way the next two, right? Then you only have apple and pineapple, right? So always add plus one to your last index, right? So that that particular index is being inclusive. So what do I mean? Let's assume I want to cut from index 0 to index 2 here, right? So now what would I do? I would just simply come here and say print. Sorry, I'll simply come here and say print, and I would say print fruit. And then here I'll start from 0 and then all the way to 2. Now, without that plus 1, what will happen is that when I run this now, I'll only have apple and pineapple, right? That's the whole point of that plus 1. So the plus 1 is so that you include that particular index that you wanted, right? Now, without it, just know that what just know at the back of your head that the n index is not always inclusive. So if you want that n index to be inclusive, you do what you simply just increment it by what? By 1, right? Increment it by 1. So in this case here, I'll do what? I'll just simply come here and just put to 3, right? And that will be what? 0 all the way to 2, with 2 inclusive, right? So this will now give me apple all the way to mango, okay? So that is it, okay? So you use slicing to do what? To retrieve more than one item at a time, right? So it will basically just cut off that list, right? And form like a new sub list, okay? Because what you have here as the response is what is basically another list. So a list is just being created from that list. But this time around, this list is just a list of 3 items, right? That is basically how you do that, right? That's basically how you do that. So you use slicing to retrieve more than one item. You use the index value itself to retrieve a single item. Okay, that is basically how you do what you retrieve things in list. Right, that's basically how you retrieve things in list. All right, so now let's look at how you do what how to create, right? Let's look at how to create, right? So let's look at how to retrieve, because I want to basically what I want to do is before I come to create, I want to talk about something, and then before we now learn that create. So we've talked about retrieve. Let's talk about update, please, not retrieve. Let's talk about update, and then we can come back to create. Then I can talk about what I intend to talk about. So that will not actually cause some confusion here. Okay. So let's look at how do we updating. How do we update an item in a list? So it's simple. It's almost similar to what we did there. Okay. So same thing again. List name as usual. So once as far as you're dealing with a structure, you always reference that structure name, right? Because since every value is within that structure, so there's always a tendency that you always reference that structure name, right? It is non-inevitable. You cannot run away from that. Okay, so the list name, and then in this case here, what the index of the item that you want to do what you want to retrieve. Sorry, that you want to update. So and then followed by what? Followed by an equality sign, and then followed by what? Your new value. Your new value. So that's basically how you update an existing value. That's basically how you update an existing value. So you select the index of that value, and then you do what? You give it a new value. So let's go ahead and let's do that. So let's just simply print our fruit here. So we see the difference, right? So we see the difference. So I want to print my fruit here. And then after printing that fruit, I now want to do what? To update the first index. Okay, that's index 0. So what I want to do, I'll simply come here and say fruit, and then square bracket 0 equals to, I'll give it a new value. This is I can give it a grape. Okay, and then so that's print fruit again. All right, and then that should now show the difference of before and after that edit. Okay, so if I should execute this now, I should now have pineapple the first time. Okay, apple the apple for the first list, and then grape for the second list. So this is basically the list after the edit. and this is the list before the edit. Okay, so that's basically how you do what you edit or you update values in that's basically how you update values in these structures. Okay. Now let's look at the create. Now before we look at the create, we have to consider what we know as list method. List method, as this create is among them, right? As the tool required for creating an item within a list is among what we call list methods. List methods. All right, list method. So what exactly are list methods? So without big grammar, these are just functions built specifically to manipulate lists. So these are functions, right? The functions that me and you know, right? The def function, like the print function, the input function, the print from here. Now these are so these are special functions, right? And that are built specifically to manipulate lists. Right. So it means that what that this function only is only being applied to a list structure, right? So outside of list structure, these functions may not actually do what function effectively as they should. Okay. So how do you apply these functions? How do you apply these functions? So these functions, they are built in. Remember, they are built-in functions, right? They are built-in functions, built-in functions that are but are specifically, I think I've made the grammar even worse. So let's take that out. So there are functions that are built specifically to my playlist. Okay. So how do you apply them? So you simply apply it to the list itself. So the list name dot the function underscore name. And then most of these functions takes what we call optional parameter. Same way, so the same way our functions takes optional parameter. Some of these functions, not all of them, sir, not all of them though, but some of them takes optional takes parameter. Okay, so depending on what function that you are using, you can choose to give it a parameter. You can choose not to give it what a parameter. All right, so that's basically how this function is being applied to list. Okay, so let's go ahead and let's apply this or see how this works in reality, right? So first of all, let's look at the function that creates an item, right? That add an item to a list. So all these functions, of course, you do not have to cram them to know what they do. Just play around with them, and with time, you will definitely understand and know what each of these functions does. Okay, so based on this instruction of how to apply them, you must reference a list structure first. So in this case, I'll reference my fruit structure, right? And then put a dot. Now if you look at my screen, right, you can see all these functions. So these are all the built-in list function, right? From append all the way to to sort. Leave the rest, leave that one down there. Okay, from append all the way to sort. Okay, so those are built-in list functions. Okay, and if you apply them to a list, they do most of from their name. They just do what their name says they do. Like this one says, and clear the list. So this one will just wipe the list. And this other one will do what we index, other one we insert, one will pop, remove, reverse, and so those are all built in list function. So the one that we are interested in right now is what is the append. Is this append that will be used to do what to add text in an argument, right? It takes in a value. So what value are you adding, right? So you simply give it that value, right? And this append will do what? This append will do what? Will add it to the end of that list. So this is basically how you can do what? Add item to your list structure by using the built-in list method. Okay, and what is the append function. So this append takes in an argument. That argument is basically the item that you want to add to the structure. So in this case, I can come here and say I want to add let's say I want to add let's say grape. Okay, let me add grape. Okay, remember I've commented on this one out, so that one will not have effect again, right? And then after that, I can simply come here and do what and print fruit, right? And then this should do what? This should now show us our fruit list, but this time with grape at the end of that list. Okay, so if I should execute this now, then there you go. You see that what that we now have a new item has been added to that list structure. So this is basically how you do how you add items to list by using what by using the append function. Okay, and let's look at the last one being what the delete. Let's look at the last one being the delete a function. Okay, so how do we delete an item? So same way we have an append, we have delete. So if I come here, there's the remove function here, and there's a pop function. Both of them they do the same thing, right? Pop takes remove a particular item. Okay, so pop takes in the index number, while remove takes in the actual value number. That is just the difference. But both of them do what they do the same thing, right? Okay. So please, in your spare time, you guys can do work and test out all these built-in functions and see what they do or how they behave. Okay, but for delete, I'll go with pop. Okay, I'll go with pop. So pop here text in the index or what of the item that you want to remove. So if I set pop 0, it simply means what remove an item that is what that is in index 0. So if I should do this and then come here and run and print my fruit, that man should no longer be there. All right. The first item being apple should no longer be there. Okay. So if I should do this now and execute, I now have pineapple, mango, and what? An orange without what? Without the apple now being available again. So that is basically what the pop there does. Okay. So that is basically that about list. Okay. So list is a very interesting structure. And as we proceed, we'll use it more often because there are some cases where we want to do what to have multiple values, but then we don't want to have multiple container or variable names. So this is where the data structure come in and make life easier for all of us. Okay. All right. So question before we proceed. Question.
Okay, I have a question.
All right. Please ask. What is the question?
We put fruit.pop 0,
Okay.
and when we now run it, apple is gone. I thought
Yes.
we would have put apple display that we put 0 for it to work. Why did we put 0 and the apple is?
Okay, so I said that this particular function called pop, it takes in the index of the item that you want to remove from your list structure. All right, so this man here takes in the index. That is why we have 0 there. So since apple is the item that we intend to remove, so what do? We simply identify the index of that item. Okay, and then you do what? We pass it to this function, and this function do what? Will remove it from your structure. Does that make sense?
No, sir.
All right, so I will explain that again. Okay, so let's use the other function, right? Because the same day the pop is confusing us, right? Let's try the other function. All right, so let's use fruit dot remove. All right, fruit dot remove. So remove here takes in what the actual value that you want to remove. All right, so in this case I'll put apple. All right, so apple here is the item that I want to remove from that list. So it will do what? It will just simply remove it. All right, so that is just the difference. Pop takes in index of that item. Remove takes in the
Okay,
item itself. Okay,
the index of the item is 0.
0. Yes, that is that. Okay, so if I should run this now, this should still give us the same result. Okay, this will still give us the same result. Pineapple, mango, orange. Okay, so pop takes in the index of that item. Remove takes in what the item itself. Okay, so both of them are so whichever one is convenient for you, then you do what you can use it. Okay. Question.
Okay.
All right. Please, I believe that helps, Miss Ngozi.
Yeah, thank you very much.
All right. Any other question? Okay, Fidelis, your hand is up. Please shoot.
I want to ask, what if we want to add an item to the beginning of the list, not the ending of the list, or in the middle of the list?
Okay, adding an item in the beginning or ending or middle of the list. Okay, so let's look at that. So so far there is a function that does that. Okay, there's a function that does that, right? So if you should also look at that fruit again, those list method, there should be an insect. So you can see insect. So that is what that function it does, right? So that function takes in the index that you want to place and the value that you want to place there, right? So let's do that. So if I use index, you can say that this index takes in two things, right? It takes in, first of all, it takes in the location. Where do you want to place this item? So if I should simply say, okay, I want to place it at index one, all right, and then it takes in that index and then the actual value. Okay, so yeah, this value I can say I want to place grape at index one. So what will happen, it will now go to my fruit, and this is my index zero, and this is my index one. So what will happen is it will shift this man forward and the one and place my grape in that particular index. Okay, so if I should run this now, so that should now carry grape and put where pineapple is. So we now have grape right there. Does that make sense?
Yes, sir.
Does that make sense?
Yes, sir, it makes.
All right, all right. Please, question. Any other question? Any other question?
Yeah. Okay. Well, how about if the scenario want to capitalize the first term
If you
of
want to
like
capitalize,
yes, just the apple and pineapple without touching the mango and
okay. Well, that can be done. That can be done. But then, don't worry. We will get to where you can manipulate each of these values. That can be done.
okay, okay.
Like, okay, because in programming, nothing is impossible in programming. So let me understand that question properly again. All right. So you're asking if you want to programmatically uppercase this first and second value, right? Programmatically, right? Or you want to just do it manually? Please let me understand the question properly, please. So
Want to programmatically capitalize only the first and the second without touching the third and fourth.
okay. That can be done. That can be done. That can be done perfectly well. Okay. So but then you need to there's no special function for that. So you need to write some scripts that will help you do that. So one of the scripts is that you can look and then you do what you uppercase it. But don't worry, we'll get there, right? We'll get there. Then maybe I can use that question and I know and resolve that. Okay. So just hold on a bit and we will answer that question real quick. All right. Another person hand is up. Chris, your hand is up. Is Chris with us?
All right, sir. Yes, sir. Can you hear me?
Yes, I can hear you.
Hello, can you hear me?
Yes, I can hear you. I can hear you.
While you were checking some functions there, I saw a function named reverse
Okay.
over there. So this object now that we just
Okay.
inserted, like just added more index to it. If we use the reverse
Okay.
function for it, for example, is it going to go back to the way it was, or how is it going to be?
Okay. So what the reverse function do is that the reverse function basically just rearranges the list from just changes the direction of the list. So if you reverse a list, it doesn't undo, all right? Because I think that's the question. If you undo, no, it doesn't undo. It simply just starts again. It switch, yeah, it flips it. Okay, it flips it. So now orange will now be the first one, and then so it will go from orange to mango to pineapple to apple. Right, that's basically what the reverse does. Okay, it will go from
Okay,
orange to mango. Yeah,
in a descending order.
yes, that's basically what that reverse function do. Okay,
Is there a
any
function that undoes?
no,
Is there
there
a
is no
function
built
that undoes it? There's no function.
no there's no function that there's no built-in function that does that. But like I said, in programming, everything is possible. You can write your own personal script that does that will do that. Okay, do you get? Yeah. So that is that. But
Yes,
for built-in function, there is no built-in function that undo list operations. All right. Any other questions? Any other question? Any other question? Any other question? Okay.
Yes, sir. Yes, sir. Yes, sir.
All right. Shoot.
Sir, what if I want to print like in this list now? Can you go up a bit? Let me
Okay.
in the mixed list now. What if I want to print this high in only the high
Okay.
in the mixed list? Yes.
All right, so that is pretty simple. Okay, so let's dive deep and let's see how that works. Okay, let's go and see how we can do a print high from that list. So first of all, let me just go ahead and just print this list. So we can have a view of it down here. So if I come here and say print mixed list, we should now have this fantastic list that we have here. But then within this list, we have a list. So there's a list inside a list. Okay, there's a list inside a list, and then all these we have. So now, if we now look at where that list is sitting, if you look at where that list is sitting, it's sitting on index. I think that was index. That was index 8, right? So let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8. Index 8. So if I should come here and say print mixed list of index 8, okay, that will give me that inner list, right? That will give me that inner list. So we have this, right? So because this is also, because that inner value is also a list, so we do what we can still treat it as what as a list. So it means that if I want to retrieve this item, say hi is still aware at index 0 of that list. So what do? Since this whole operation now is just that inner list, how do we retrieve item from this, right? You simply do what? You simply reference the list followed by what? Followed by the list index, right? So this is that list, right? The inner one. So I can do what? I can simply come here and reference the inner one. That's the item of that inner list. So just add one more bracket there, add 0, and that will give me high from that list. Does that make sense?
Yes, sir.
All right. But just to make even make it more better, I can even call this sub list, right? Sub list. So and then copy this, cut this out, and just put this is equal to that, and then reference sub list here. So you see the same thing, right? So remember, reference the list name and then the index. So you see the same thing, yeah? You see the same thing. Yeah, hi. All right. Any other question? Any other question before we proceed? Any other question?
So why did you add 0 to that instruction? I thought the index of high is 8. Why did you put 0? I mean the first one you printed.
All right. So this particular 0 here. Now you know that if I should do mixed list of index 8, that this man here is what will return this, will return a list structure, right? Of high, right? And then I think there is there. I think that and I want to validate, right? So now I'm simply saying, okay, once I retrieve this list, which is this, I want to get this first item that sits at index 0. So this is why I put that 0 there. So this 0 there means this item high that sits within this bigger list. Do you understand?
Okay.
Are we together? Yeah.
Yes.
All right. So let's proceed. Okay, so that is basically that about list, right? That's basically that about list. Okay. So that is how you manipulate list. That's how you store things in list. That's how list structures behave. Okay. Now let's dive deep and let's look at the other remaining structures. So the tuple structure, the tuple structure is a very fantastic structure. Okay, so please, one more thing that skipped my head, right? During this list definition is that this is basically a mutable. Please put mutable there because it is very, very important that what that list is what is mutable. It means that the content of that structure can what now the reason why and I remember that keyword is because tuple, on the other hand, is an immutable structure. So that is why, and I remember that mutable place. List is what is a mutable collection of values, right? It's a mutable collection of, it's a mutable structure. How do I put that? Hold on. Let me just find one fantastic space and put that mutable. That mutable sounds up there. All right. I think it fit that place, please. This is not English class. Let's just manage it there. Let's manage that keyword there, please. So it's a mutable collection of values. So we type by corner and by commas includes with the square brackets, yeah. So please, but if that keyword there is it's not going to sound somehow, please remove it and put it where it sounds well. It sounds well for you guys. But for me, that man sounds fantastic. Right, that man there sounds fantastic. All right, so please let's dive and let's look at tuple. So what exactly is tuple? So I'll just copy the definition and then I'll just edit it down there. Okay. Here, let's see. So down here, I have what tuple as a data structure and also as a data type. So tuple data type and also a data structure. So basically, is what is an immutable, right? Is an immutable. This man here cannot be mute, right? It cannot be edited. So it's an immutable collection of values separated by commas enclosed in parentheses. This man here doesn't use square bracket. This man uses parentheses. Parentheses. So parentheses is basically this man. That's basically what tuple use. So the values can be of any data type in Python. The order of these values also matters. Okay, so there's nothing really much about tuple since tuple is what is immutable, so you cannot really manipulate it. So once you create a tuple, it is fixed, right? That values cannot be changed. That values cannot be altered. That's basically what tuple is. But then you can retrieve the values. In fact, anything that relates to changing the values within that structure cannot be done on tuple. But then anything that relates to retrieving, of course, you can retrieve just retrieving, where you can also count, you can do anything, but then you cannot change the state of that structure. Okay, so let's see how tuple look like. So this is basically what a tuple looks like. So I'll just copy what our list structure up there and just work with it. So I'll copy this man and bring it down here. All right, and then I'll call this man T as tuple, and this is what tuple looks like, right? So this is a valid tuple, right? That man there is what is a valid tuple, basically what a tuple with no values in them, okay? And then I can also have a fruit of tuple. So this man here can change it to fruit. So to tuple by simply doing what? By simply just putting this man there, okay? Same thing happens there. I can do this, right? And do this. And I can also have another tuple structure. So I'll come here and add another tuple structure. And here I can have 100, 200, and also 300. Okay? So that's basically what a tuple look like, all right? It's an immutable data structure, and everything about list retrieving still works with tuple. Okay, so if I come here and say print t, print fruit, and then print mixed. This should be mixed tuple. Okay, so I'll edit this man and put this man here. Okay, and that is that. So if I should run this now, this should just simply just display is similar to list, except that this man here cannot be edited. So what do I mean? If I try to do something like this, if I try to say, okay, let fruit, let me select the first index. So every operation that works on list works on tuple, right? Every get operation, that's every retrieving operation that works on list works on tuple. So the same way you retrieve a value in list is the same way you retrieve a value in tuple. Okay, so you see the same thing. The only difference is that tuple cannot be edited, right? Once it is being created like this, it is permanent, right? So you cannot alter that value, right? So if I try doing something like this, say equals, so let's say I want this to be grape, okay, and then try to execute this, then this will throw an error saying that what, that tuple, it does not support item assignment. So this grammar here simply means that what, this big grammar here simply means that what, that the content of that tuple cannot be altered. That's basically what that grammar there means. Okay, but then every other thing works. So if I want to retrieve, say print, I want to retrieve the first item, I can simply say T and then the first item, and that would sorry, not T, fruit, and that will just what, that will retrieve that first item. Then sorry, that's the other way around. This should be fruits. All right, and then if I run this now, I have what, I have my apple. So the other ones are showing because we still have those prints up there. So if I should take this out, comment on that and run and execute this. Then we have our apple, right? So that's basically that about tuple. So there's nothing really much about tuple, nothing really to explain about them. Just that what, that tuple are immutable, right? And in most times it's useful if you want to have a fixed record that you don't want to change. Then tuple can come in handy, right? Then tuple can come in handy, yeah. All right, so that's that about tuple. Question. There's nothing really much or about tuple. Question. Any question pertaining to tuple? Any
Can you?
question?
I think I didn't get this. So is it that the T itself is the top or the bracket that we are using?
It's the brackets, right? So the bracket is what differentiates it from a list. So the list use square brackets. You can see list use square brackets. Tuple use parentheses, your normal brackets, okay? So once you see this kind of structure, you simply need to know that what, that the values or the contents within that structure cannot be changed. But then the contents can be retrieved. Whereas you can retrieve those content, but you cannot alter it, okay? So like what I did earlier, that I tried to do what, to change the value. So you can say that it threw an error. So even if you even try to check for tuple built-in method, you can see that there's only count and an index. Okay, there's only count and index. So these are functions that will not alter the structure of that, of sorry, that these are functions that will not alter the content of that structure, right? These are functions that will not alter the content of that structure. So that's basically what tuple is. So once you see them like this, and this bracket, right, you simply just know that what, that the content within itself cannot be altered, but then it can be retrieved, right? But then there's also another catch. Most times your tuple can have a mutable structure, right? So what do I mean? Like, look at this mixed structure here, right? We have a list, right? And then we all know that what that list is, what is mutable. So what do I mean? It means that what, that the content within this man can be changed. But then generally outside here, this man cannot be changed. So what do I mean? I cannot delete this structure out completely, right? I cannot like delete it out completely, but then I can change any of these contents within the structures, right? I can even change it to no structure, like to no value and within it, right? But then that structure must still be there, right? Because what that structure was already there during the time of what, of that tuple creation. So how do we do this? So it's simple. So if you have a structure within an if you have a mutable structure within an immutable structure, you do what, you simply just select that structure. So it's similar to what we did earlier. Can simply come here and say mixed list, and sorry, this will be mixed tuple, not mixed list, sorry. Mixed tuple, not mixed list, mixed tuple, and then index X. Remember that man is sitting on index X. So if I should say print this man, if I should print this man, then we get to say that we've now fetched that immutable structure within that immutable structure. Okay, so we now have our list there. So these are the ones that we can do what edit. We can change this content, but we cannot delete this structure out completely. Why? It's because when doing your creation, it's already registered that on index 8 that is a list there. So you can only delete the contents of that list, but that list is still there. So basically, what an empty list. You can also change the contents of that list if you want, but then the list must still remain. Okay, that's basically what I mean by immutability and having a mutable structure within them. So let's assume I want to change hi to hello. What do? I can just simply come here and say select that mutable structure, right? Select that mutable structure, select the index of that content, which is what 1, and then do what? Give it a new value, say hello, right? And then if I should now come here now and just say print fruit, fruit, you can say that the content of this one here is changed, but then this tuple here cannot be changed. Okay, so if I run this now, I should now have hello. Where are you? So that did not actually work. Let's see. Sorry, that we should have printed mixed tuple, not the other one. Okay, so let's do this. Let's go ahead and let's run again. Then we have what we have hello instead of our there. We now have what hello. So you can say that the values within this structure. So these are the only things that we can edit. Those are the only within that boundary things are mutable. But outside of that boundary, everything here remains what immutable. Do we understand? Do we understand?
Yes, sir.
All right. Question before we proceed. Question. Okay, so the silence means no question. So let's quickly look at the last structure, dictionary. Please, you guys pay attention. You guys can always look up. What set. Right, set is another wonderful structure that it comes in handy. Right, come most times. Right, so please look at it and you guys pay attention. Right. Okay, so let's look at dictionary. So what exactly is a dictionary? So let's also go and copy again this definition. Right? And then let's bring it down here. And we said that what a dictionary is basically what a mutable. So dictionary also what can be edited. Dictionary also can be edited. So it's a mutable collection of value pairs. Please take note of the name. It's no longer value, but then value pairs. Okay? Separated by comma, enclosed with a coily braces. With a coily braces. Okay? And of course, the values can be of any data type in Python, and the order of these values does not matter. Does not matter. Does not matter. Right, that's basically what a dictionary is. Okay, sorry, this should be dictionary. This should be dictionary. Right, so dictionary data type or data structure, they are basically what a mutable, not an sorry. They're basically a mutable collection of value pairs, of key value pairs, right? So this should be key value pairs. So this should be key dash value pairs separated by comma enclosed with a curly braces. By curly braces, I simply mean this man, these other brackets that look like this. But that is basically what a dictionary is. That is basically what a dictionary is. That's basically what a dictionary is. And let's see how we can create these dictionaries. So that they're pretty simple. But then the key thing that we should put in mind is that the content of dictionary come in pairs, right? The key and the value, right? The key and the value. The key and the value. So the values can be of any data types in Python. The keys must Sorry about that. Sorry. The keys must be unique. Right. So please note that these values can be of any data types, and it must not also be unique. But here the keys must be unique. So you cannot have the same key twice within one single dictionary structure. So that is just a difference between this dictionary and the rest of the other structures. So dictionary help us to not remember where an item is. So remember when you are dealing with list and tuple, you have to memorize where a particular value is. A particular value is sitting, or a particular index of value is sitting, right? So, but with dictionary, you don't have to do that. The only thing that you have to do in dictionary is to remember the key, right? So the key is what is the means of identification. That's basically how a dictionary is being declared. So it follows this standard. So you can have a dictionary here called D equals to what? This, right? And then it takes in the key, and then it takes in what the value. So each key, so this is one single value in this dictionary. This is one single item within a dictionary. So one item comprises of two pairs, right? The key and what the value. And where the key is being separated with what we colon from the value. So please, this is not two items. This is what a single item in that structure. Okay. So of course I can have multiple keys and multiple values. So I can have comma, another key, say key 2, and then value 2, right? And so on and so forth. That is basically how a dictionary is being created. Okay, that is the structure of a dictionary. So a dictionary item comes in pairs, right? The key and the value, the key and the value, the key and the value, and so on and so forth. Please, this is one single item, and this is one single item. Right, so please, this is not 4 items. Those are what 2 items within that structure. Okay. Now let's see how we can how we can uh, replicate or create our dictionary with fruit. Or let's say yes, our fruit dictionary. Let's just go ahead and do that. So let's come here, or probably let's just have a mixed dictionary. Let's just have a mixed dictionary. Okay, a mixed dictionary. Okay, and remember, your dictionary is separated by what by each item in this structure. It comes in what comes in pairs, the key and the value. So your key have to be unique. You have to be anything that cannot repeat. So here I'll just stick with simple keys. Here I'll call this item 1, and then maybe I can just call this maybe item 1. Yeah, item 1 is fine. You can call yours anything. So here I can have my number 1 as a value. So please, the only value in this structure now is 1. This is a key. It's simply used to do what? To uniquely identify this value for 1. Okay. So please, this is not your value. This is your value. This is the identification of that value. Okay. So that is how dictionary work. Okay. And then I can have another key. Here I can have item 2, and I can have a float, say 20.6. Okay. And then I can have item 3, and here I can have a list, say 1, 2, 3. Here I can have another item 4. And here I can have a dictionary again as value, as the value of this particular key. Okay, here I can call this inner item, and I can call this 100. I can call it another inner item, and I can call this 200. Okay, and then maybe I can have a one Boolean value for true. One Boolean value for true, and then okay, I can have item. I can have another item here called item 5. and so on and so forth. Right. So this is a typical example of our mixed dictionary. How many items do we have in that structure? How many items do we have in this structure?
5.
How many items is 5? Fantastic. So we have just 5 items in that structure. Please, this is just 5 items in this structure, right? So remember, each item in a dictionary, they come in pairs, right? The key, the value, the key, the value, the key, the value, and so on and so forth. Okay, so this is a typical a dictionary in Python, okay? And of course, we can also have an empty dictionary. So can also have an empty dictionary, and this is also going to be just that. And all these are all valid dictionary structures. And I can simply just print them by simply saying print a mixed dictionary. And I can also print empty dictionary. And if I execute this now, we should have our dictionary there, right? We should have our dictionary there. So we have our dictionary. Okay, so something is still printing up there. So let's take this one out. And then come back and run again. So we have our dictionary now. Yeah, and what the empty dictionary. Okay, so that is basically how dictionary work, right? That's basically how dictionary works. And trust me, you don't have to memorize where a value is. You just have to know where the key that is assigned to that particular value. That's all. So dictionary works with key. Dictionary works with key. List work with what? List and tuple works with what? With indexes. Okay. That is why the order of your values within the structure matters. But here in dictionary, that value does not actually matter. Wherever it is, it will just work just fine. All right, so let's go back. Let's do that. Let's go into what the manipulation of these structures, right? Let's go into manipulation of these structures. So, still considering our crude. Let's see. Considering our crude. Let us see what we can do. So, how do we create an item how do we create an item for a dictionary, or how do you add new item to a dictionary? So it's simple. You do what you reference the dictionary name. Sorry, this should be lowercase. Dictionary name, all right, and then reference by what? The new key. So basically, by new key, I simply means a key that does not actually exist in that structure. So if a key actually, if you use a key that already exists, then what will happen? It will do what? It will override that value. Okay. So you want to assign a new key and then do what? Give it a new value. A new value. Okay. So let's go and let's see how that works. So let's go ahead. Let's add another item to our mixed value. So here I can just simply say mixed value, or sorry, mixed dict, and then here I'll give it a new key, a key that does not actually exist, and I'll call this name, right? And then I'll call this KodeCamp. KodeCamp. Okay. So if I should now go ahead and print my mixed dict, okay, I should now have KodeCamp now added to that structure. So with own key called KodeCamp, of course, call name. So we now have it here, name, and then the value called KodeCamp, right? So that is basically how you add to dictionary. So it's that simple. So you can say dictionary is one of my favorite structure, right? I don't really like tuple and list because I have to somehow remember where an item is. But with dictionary, I can just just fetch it by the key, right? That's basically the beauty of dictionary. Okay, so that is how you do what that is how you add items to dictionary. So how do we now retrieve? Okay, let's see how to retrieve. So to retrieve, it's simple. All right, just reference the dictionary name. So dict name, dict underscore name, and then in brackets the key. Right, that's simple. Right, dict name and then what? The key. And then with that, you've just done what? Retrieve the item from that dictionary. So if I simply come here now and just say print, so let's print a mixed dict, and then I want to give this item. Okay. And then if I print this now, I should now have 1 as the value, right? That is that. So please, you retrieve by the key, with the key rather. you retrieve with the key. Okay. So if I want to retrieve this list here, right? If I want to retrieve this list here, so I just need to retrieve it by what by the key, which is item 3. So if I should not execute this now, I should not get my list, which is what we have there. Okay. So that is how you do it. That is how you retrieve. So how do you now update an existing value? So it's simple. It's simple. Updating of value is simple. It just the same thing here it's the same thing here. Do what? Reference the dictionary name and then give it an existing key, not a new key. So existing key and then the new value, right? Existing key and then the new value. Okay, so if I should come here now and simply do this, call this mixed dict, okay, and then I want to alter the face value from 1 to, let's say, to 1,000. Okay, so if I should now come here now and just say print our mixed dict, I should now have item 1 now being what? 1,000 instead of 1. So we now have 1,000 there. Okay, we now have 1,000 there. So that's just that, right? That is just that. Dictionary are just simple and straightforward. These people are just too, they're nice, very nice people. All right, let's go ahead and let's see how do we now delete. How do we now delete? So to delete, you simply do what? You simply use this keyword called del. So del is used to delete, right? And then so del and then followed by the dictionary name. So the dict name, dict underscore name, and then the key that you want to delete, right? So so you delete by key. So in dictionary, everything is done by key, right, and not by index. So to do that, we simply just come here and say del, right, and then I can just say delete this man, the first item, which is what? Item 1. So if I should now print my mixed dict, I should now have the structure but without the item 1. Okay, so if I should run this now, that should now kick off item 1 and give us just item 2 all the way to the last. So that's that, right? So you can see that item 1 is no longer available. All right, so that is basically how this dictionary works in Python. Question. That was fast. All right, so you can see that what the dictionary is pretty simple. The dictionary is pretty simple. Question before we dive into one more concept and then we wrap it up for today's class. Question. Question. Okay, so the silence means no question, that we fully understand the concepts of dictionary, list, and tuple. That is fantastic. So let's look at one more concept and then that will be all for today's class. So all of us can just go and take a rest and maybe go through. How many of us that downloaded that PDF that I mentioned on Monday?
We did though.
Okay, so how is it going so far? Have you been able to solve any tasks based on the topic that we've covered so far?
No. I've been just I was working on this thing. What do they call it? I was on variables and
Okay.
for loop. But I was
All
having
right.
issue in one exercise like that where they say we should print
Star.
Fibonacci numbers.
Okay, Finabuchi now, Finabuchi. Okay, yeah. It's a very simple concept now. You guys can just do that one now. Just if you can just write out the algorithm, because basically how does that sequence work? That sequence work starts with two numbers, 1 and 1, right? So basically you have to
Yes.
write code, you have to write code that will continue with the rest of the number. So the next number there should basically be the sum of the previous last two numbers. So 1 plus 1. So the next one now should be 2. And then the next one should be what sum of the last two numbers. So now 2 plus 1, that is what? 3. And so on. And the next one what is 3 plus 2, and so on and so forth. So this thing is logic, right? If you can see the logic. And okay, if you can write the algorithm, right? Trust me, you can solve it.
I will
Don't go
try.
and use don't go and use AI. Oh. Now, we're not waste time. We're not-
I will, I will
All
try.
right. Any other person that downloaded that book?
Yes, sir.
Okay, how is it going?
Please, what? Okay. Is somebody on?
No, 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 no. You are active. Please continue.
Okay. This CRUD.
Okay.
What did you say it is?
Crude. Create, update.
Um,
Sorry, it creates, retrieve, update, and delete.
okay. Thank you, sir.
All right, sir. All right. Any other question? Any other? Who again downloaded that PDF? It seems only one person downloaded that PDF. Please download that PDF. Uh,
I did.
and okay. So I think someone has been mistaken bit. Okay, please, that PDF would it may be old, all right? But trust me, the tasks in that PDF, if you can solve them, if you can, you don't have to solve all the tasks at once. You can always solve and come back, because this thing works like this. The more you read that book, the more you understand certain concepts. So you can always come back and solve certain tasks that you skipped, right? Trust me, if you can solve those tasks, that book would expand your thinking in a way that you don't get any tasks again for this programming. Who you know face off. Trust me. Please, I really recommend that. This week is there's no professional tax this week. So please, I'm begging us, please download that book and at least try and solve some tasks pertaining to the topic that we've done, right? And then also read their own explanation. You can see that what that it add more understanding to what we've done so far. And before you know it, you'll be solving tasks left, right, and center. Okay. So please, I really want us to be perfect. Not perfect, because of course they're not perfect developer, but I want us to have that critical thinking, the ability to see question and look at it critically and dissect it, break it down, and bring out, even if you can bring out the algorithm. Algorithm solves 60% of the problem. In fact, if you can bring out algorithm of solving that task, you solve that task 70%. That means 30% is just coding. Just carry concept and jump a concept and you're done. Right? That's just how programming works. Okay. So please, let's go back and let's look at that book again. All right. So before we wrap it up, let's look at loops. Okay. So you're
Yes,
wondering
sir.
why we now. Sorry. Question.
Uh, yes, the book you're talking about, is it the Practical Introduction to Python?
Yes. Please. It's
Okay.
it's it's very essential. Right. I recommend that book, even though it's old, but the content is still valuable. It's still valuable. Please. In your spare time, you guys can just look at just go over it. There's no promotional tax this week, so you guys can can play around with some of those tags there, right? Okay, so let's look at loops. And you're probably wondering, why are we going back to loops? And we passed loops. Yes, we passed loop. But remember, during our loop classes, we said that that loops is basically used to iterate, or to do what to repeat an action based on a number of items that are in data structure. Now we have covered data structure. All right, so your loop works here as well. Okay, so I want to simply just solve that task. Someone ask a question. What if I want to just edit and to uppercase the first and second content of my list? All right, so this is basically where loops can come in. So you can iterate over the content of your structure and then do what play around with it if need be, right? And play around with it. So let's just do that so that we can just see that how loop works with the data structure. It's not as if we want to do something new, right? We just want to introduce it so that you guys can see that of course loops can also be used with data structures. Okay. So I want to look through our list, right? This man, because remember, it is only list that we can alter. We cannot alter tuple. Of course, we can also look through the dictionary and also alter it. But for this particular exercise, I want to look through this particular fruit. So I'll call this man the L fruit so that it differentiates from the other fruits. So I'll just copy that name and bring it down here. Now say for same syntax for item remember item there is my variable name, okay? For item in L fruit. And then I can just simply just print item, okay? If I print item, what would I have? I would just have the content of my list, right? Remember, and for each time you repeat something with list and with a loop, right? The content of that structure is being assigned to your loop variable. We explained this now, right? In our previous class. So this is that, okay? So if I should run this, I know what I now have the content of my structure, which is apple, pineapple, mango, and orange. And I think someone asked, what if I want to do what uppercase apple and pineapple? How do I do that? All these things is just logic, right? All these things is just logic. Okay, so there are several ways that you can do this, right? First of all, you can just simply check if if first of all, okay, one way is if I check it when item is what when item is equals to what your apple, right? Remember, in this case, you want apple and pineapple, right? Then if that is the case, right? If that is the case, I just want to come up here and give it a variable. I'll call this variable our new list. New list. That's going to be an empty list, okay? Right, and then inside my loop, I simply just want to check that if the current item or the current item that we now have in that structure is what is apple. What do I want to do? I just simply just want to do what? Just simply just want to do what? To uppercase it. So I will just say swap equals to what? Item dot upper. So there are also string methods. So the same way we have list method, there is string method. So there are methods that is built specifically for strings. That when you apply them on a string, the same way you apply it on list. If you apply this one on string, it alters that string, all right? It alters that string. So this is just this is all the string method. And you can see that string methods are very much. So one of them is what is uppercase. Oh, sorry, capitalized, rather. So if I should do this, then this will do what? This will just carry that man up and change it to what? To capital letters. And then I can do what? I can just do a new list dot append. I want to append what? The swap. That's the swapped version of that of this our stock. And then I can also check again elif again, elif the item is equals to pineapple. Elif item is equals to pineapple. Then same thing again, swap, right? Swap. And then else, right? Else. Just do what? Just simply just append the item, right? Just append the item like that. Append the item like that. Okay? And then at the end of the day, I'll do what? I'll just simply just print my new list. Okay, and now we should now have the new list with the first two items swapped to uppercase, and the other ones are just the way it is. So if I run this now, we should now have okay, that did not happen. Okay, so that uppercase, but then that capitalized, but it only capitalized the first value. All right, so I think I misused the function. So I think there's uppercase rather upper, yeah, or the upper, not capitalized. So capitalized only changes the first. Sorry, guys, sorry. So capitalized only changes the face value, right, to uppercase, but upper here changes the entire string. So if I run this now, I should now have my oh god. Sorry, guys. Okay, so now I now have what the upper version of what the apple, the pineapple, and then mango and orange still remains the same. Does that make sense? Is there anyone that understand this script? Anyone that understand this script?
Yes, sir, but there is one other concept I want you to explain for them. I
Okay.
used to see most is upper dot strip. Yes, something like that.
Okay, dot strip. Okay, so
Yes.
dot strip. Okay, strip. Okay, so from if you look at this thing here, from like this pop-up, you can simply just read what that function does. So this function here returns a copy of a string with leading and trailing white space removed. So what does it mean? It means that if there is a space within before and after your string, it simply just remove it. So what do I mean? Let's do this. Let's come here. Let's say so now we move from list. We are now in string. Or so we move from after string is also sometimes strings are also considered as data structure. So it doesn't matter. So let's assume that I have a name equals to let's say let's say I have a name equals to CodeCamp, right? CodeCamp, right? And then let's assume that I want to simply say if name, right, equals to CodeCamp, right? If name equals to CodeCamp, right? I want to print true, right? Now if I run this now, what happened? Of course, it is what it is true, right? But let's assume that this name was coming from user input, and for some reason the user have added space somewhere. No, this thing happens even when we are typing in when filling form, and then we have keyword suggestions. When we click on it, it of course automatically will add space. So these things can happen, right? So now if I should now run this code again, then this now becomes what? False. Because CodeCamp, sorry, because name is no longer what? CodeCamp. It's now CodeCamp with a space at the front. So to avoid this kind of situation, you will just simply just come and say if name dot strip, that is basically remove any white space before and after the name is equal to CodeCamp. Then if this is still true, in this case, this is now what? True, because that white space that was there will now be removed. So that is basically what the strip there does. It removes white spaces. Okay, it removes white spaces in string that at the beginning and also at the end of that string. Except this space is in between. Then unfortunately the string cannot do work, cannot help you again at this point. Okay, so if this was the case where this space is here, then this is now false because strip cannot remove spaces in between in between spaces. Okay, only at the beginning and at the end. Does that make sense?
Yes, sir.
All right. Question. So please, that is basically how I think the person that asked that question, how we can do that. So this is how we can do that. Okay. Also, there's also another way which I want you guys to go and think of it. So which I want you guys to go and think of. Please don't use ChatGPT. So assuming that our L fruit, right? That the first item. Okay, this one is just like a take-home task, not to submit a shower. What if you can do it at time when a group, no problem. I can come and just look at it. But this one, I'll not grade you. So let's assume that our L list, let's bring it down here so that we don't have to screw much. Let's assume that our L list is this, okay? That in this case, our L list here is, or let's say we have another item called grape, comma, apple, right? And I also have another item, say, pawpaw, in this case, pawpaw, right? And then that's okay. So in this case, I want a situation where if I have this L list without explicitly changing apple to grape and this to pawpaw, right? I want to do was still fix this situation. I want grape and pawpaw to still be uppercase, right? Without regardless of what first and second item is, right? I want a situation where regardless of what first and second item is, I still want them to want to be uppercase. So you guys can go back, and look this code and see how you can change it and get that to work. Okay. So what do I mean? I don't want to always come inside your loop and change the content of this loop, right? I only want to do what change the content inside this list, and it will still do what work by converting first and second to what to upper case. So please take it home and take your time and do what and get it done, right? I will not. It's not forgetting. It's just for you guys to go and do what to go and play around with that particular script. Question before you wrap it up. Question.
I don't really get your question very well. Is it that we are not
Okay.
going to slice through it, or
Of course, anyhow you guys want to do it. Why want to slice it? We want to loop it to anyhow. But the problem is that if I should run your scripts, let's assume I want to. Okay, let's do like this. Let's do like this. Okay, let's do like this. So that it makes sense. So that it makes sense. Okay. Let me take this man out. Right. Let me take this man out. Okay. And then let's make this. Let me duplicate this. So this will make sense now. Let me duplicate this. Then remove this. Okay. And then let's change this to what to a list. So I want to take in a list, right? So and then a list of inputs. Yes, a list of inputs. I say enter your list. Enter your list. Yes, this will make sense now. Okay. So now, if I should copy this list, right, and enter it from the input, right? Of course, this will work, Abby. So let me comment on it out. Let me comment on this man out. If I should execute this code and paste my list inside here, enter. Okay, that did not come as expected. Please hold on. Hold on. Let's hold on. Just hold on a little bit, please. Let's give me 1 second. There's how you can collect list. Just keep my head. Just give me one few. Just give me. Let me just confirm that. Uh, uh, hold on. 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 Mm, okay, let's see. Let's see. So I learned this particular concept from that PDF. So that PDF showed that this concept of collecting lists.
so I check your
Uh,
item.strip. That is ST. I think that is where the problem is coming from.
okay, I haven't actually. I'm not even used that strip yet, Abi. Yes, Abi. Okay. Hold on, wait, let's see. That's upper, and I want to put them the upper. Okay. Okay, so I'm not even sure that is coming from there, but let's see. Mm, I can't remember that thing now. Can't remember that thing now. Okay, let's do like this. Let's use eval. I think there is a keyword called eval. This thing just keep my head. Let's see. Let's try eval. Eval should help us. Let's see if eval does that. Yes, eval does it. Okay, so eval is the keyword that's the one that I was looking for. All right, so what eval, if eval there just means evaluate, okay? That it's a special keyword in Python. So this keyword, I learned it from that PDF. So you guys said that PDF is still valuable to me. So now I still know use of concept that I learned from that PDF. Okay, so you rarely see eval in online articles, right? You rarely see it, but it's there. I think it should be in the first chapter. You should see eval. All right. So with that eval, I can do what I can put my list now. Okay, I can put my list now. B, and when I put my list, what happened? Okay. Let me copy my list again. Hold on, please. Let me copy the list. Where is it? Oh God, seems we've lost our list. Hold on, first. Okay, so there it is. So, but enter now. So what do you guys see? My apple and pineapple is what has been uppercase, right? And that is what we want, right? But let's assume that I have this kind of list now. Let's assume that I now have this where I now have inside here now I now have let's hold on. And I now have grape, and I have papa. All right. Now, if I should click on enter, what do you see? You see, the third and the fourth was uppercase, right? Instead of the first and the second. So my task now is that you guys should go back and do what and see how, no matter what the list look like, the first and the second will always be uppercase. Do you now understand the task?
Yes, sir.
All right. So please take your time, play around with it. Don't go and copy it and give ChatGPT. Just try your best. All right, just try your best. Look at it again and see what you can edit. And it's just small changes there, and that problem there is solved. Okay. Question pertaining to today's class, if possible, about the tax too. Question.
I don't think you make use of the empty list.
You mean this empty list? I've used it. I used it here. See them there, right? I used it. So all these things, I simply just appended it to the empty list, right? And then at the end of it, I created the new list. So before my loop, I just created one empty list and then did my edit and just added back to the new list. So that will now form the new list now. And then I now printed it out. Do you understand? All right, Mr. Chris, your hand is up. You have a question? Mr. Chris. All right, so I think Mr. Chris is no longer with us.
I have a question.
All right, please.
This last one you are showing us,
This
I
this
didn't I didn't see where uppercase is mentioned here. Is it the vowel that brought the uppercase in that command?
No, 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 no. This is where the uppercase is being used. So upper, that's basically where it's being used. So I'm simply just saying convert this item to uppercase. So upper here is a function that actually converts strings to uppercase. Right. So that functionality came from here and not from the verb, right? It
Okay,
came from
okay.
here. Yeah. Any other question? Any other question?
Please, what's the function of a val in that code, sir?
All right, so a val is just is a built-in keyword, it's a built-in function rather, that simply just stands for evaluate. Right, so it's a very powerful keyword. All right, so like I said, most of these keywords or most of these built-in functions, you just see them inside that PDF. So one beautiful thing about evaluate is that it can just you can carry out arithmetic operation within your input, and it will still just work just fine. So that's what that function there does, right? It's a very powerful function. So, but it stands for evaluate. So evaluate just simply means evaluate, like carry out any arithmetic operation. So let me show you one simple example. So let's assume that I want to print what this man is. So I can just simply say print if I say print L fruit, right? And then inside my then inside here inside this input, right? I can just come here and say, okay, that I want the value of L fruit to be 60 plus 20. And evaluate will do what? Evaluate will just simply add that and give you as 80. So that is just the beauty of evaluate. It's a very powerful and fantastic function, right? But these are functions that people don't really talk about. So that is what it does, right? So, but because it's a powerful function, it allows you to do what, to paste your list as it is, and to see it as list. Okay. Now, without it, if we paste the list will just will come in as string. I think we saw the output earlier. So, but with a val will just see it as a list and pass it to pass it to your code exactly the way it is. So that is just the function of that val there. Any other question? All right. So the silence means no other question. Please, in the absence of any question,
Hello, sir.
fantastic.
Can you like put the
Can I do what?
you know
Can I do what?
can you put the results of what you want us to be as a comment?
Okay. So the result is basically and if I put in any list, just uppercase the first two items. That is just the result. Okay. If I put in any list of my choice, okay, just uppercase the first two items. If I put in a list of just one item, uppercase just the first item. So basically, this is what I mean. Let's say I put in this list, right? This list of, let's say I have a grape here, and I have a yeah, right? Your scripts should return something like this. Your script should return something like this. Uh, grape, okay. Even if I put just two items in this list, it should still return something like this. It should still return something like this, right? If I put in just one, right, it should still return something like this, right? So that's basically how what your code should do. The first and second item should be uppercased, whether it's just one item or two items or three items, right? But then first two must always be uppercase. So that is basically what you just do for me. Do you understand? All right, Anthony, your hand is up. All right, Anthony has Japa and Lagos. Okay, so that is that. In the absence of any other question or any other thing, please,
Good evening, sir.
good evening, Mr. Anthony.
Sorry, please. At the end of the day, I just want to like get the whole data structure straight. Um, the list, in what scenario can the list, the tuple, and the dictionary be used in your programming? Because all of them seem to have one particular pattern or flow. Just some is square bracket, some a curly bracket, and okay, dictionary curly bracket with key and value, and while tuple and lists want to almost have the same similarity. So, in what cases are they used? Like, just give a scenario or something.
Okay, so data structure play a very important role in program as far as programming goes. Okay, so first of all, we can use it in situation where we want, especially in situation where we intend to have a collection of values. That does it. Where in situations where we have to send out or receive or process or store a collection of value. That is more than one value at a time. That is where the data structure can come in. And most of them, they are used as in memory, um, in in memory storage. Yes, they are using as in-memory storage in most cases. So basically, you can use them to store things while your programming is executing, and you can retrieve and manipulate those things without. So, a typical example was the inventory system that we built. Okay, so since we don't have database, most of us make use of dictionary as database as an in-memory storage. So you get. So those are the places that data structure can come in. And also, even if when we get to back in proper. When sending out data, that data must go out in a particular structure, right? So as far as data collection and retrieving and manipulation is concerned, data structure is inevitable. Do you understand? Are we together?
Yes, I understand. But what I was saying is, can I choose? Let me say you give a task. Can
Okay.
someone choose to use a list while another uses a tuple? Will it like give the same thing?
Uh, um, let's assume that you don't have a typical values that doesn't really require means of identification. Then lists can do just fine. Okay, so each of them have important roles that they play. So it's left for you as the developer to choose the structure that works well for you. Someone like me, I will always think dictionary, right? Worst come to what I'm even try list. I barely used to go, barely, right? But then it still boils down to what to the developer and what you see fit for that particular task. If you are seeing dictionary it is. If you are seeing this list it is, right? The aim is that what is that what use it and solve the task. Okay. So it's developer's choice, right? These structures are developer's choice.
Okay, I
Are we together?
understand.
Yeah.
Yes.
All right. Any other question? Any other question?
Yeah, yeah, yes, sir. I,
All
I
right.
think earlier in the class, you were saying something about that one can know the number of items on the list that
Okay.
we work on it. What if in a case where we don't know in a case where we are building a system, we don't know the number of users that can put in data on that user and we want to use the data. Is it Can we use it in a list?
Yes,
In a
since
list.
yes, so since remember these are structures specifically meant for what to collect multiple values, right? So in a situation where you want to collect data from user, the appropriate place to put them is any of that data structure, right? And list or dictionary. Okay. So
Yeah.
so I only said that when you are looping through a list that list I only said that for loop is used to look through and to repeat things based on the number of items we have in a particular structure. Okay. So I never say that the structure have a limit, right? I only say that the limit of for loop is tied to the contents of the structure. I don't know if that makes sense.
Okay. Okay.
Yeah. So your structure itself can carry as many values as possible. But those values now is now the limitation of what of for loop. So for loop now will only repeat things exactly the number of items in that structure. All right. But the structure itself can have as many values as possible. Okay. Any other question? Any other question? All right. So the silence means no other question. Please do have a fantastic good night rest. Please take your time. uh, do practice, please. I cannot stress it enough. Practice, practice, practice. Right? It makes you a better developer. You don't even need to practice to write code all the day. Right? 1 hour. You can use your phone because at this point we are doing the basics. So you can use Python. You can use an online compiler, right? And just practice. Come up with a task in your head and then try and solve it. Okay. And by so doing, you become better, not only at programming, but at critical thinking. Programmers are one of the best critical thinkers because when someone is telling you a task. You as a developer, you're already picturing the possible ways of solving that task, because that is basically your role. In fact, if you look at, if you go to Indeed or all these job boards, you see that most of the requirements for developers is what is ability to do to think critically, because that is what makes you a better developer, right? The ability to think and come up with solution, right? So please, this week is no tax week. Practice on your own. Look up algorithms. You don't have to go deep. Just look at and come up with tasks. Write out the step of how you possibly solve that task. Do what try to do what to implement those steps programmatically. Okay. So you don't have to wait till your PC is on. You can always practice with your phone. It will still execute just fine. Okay. So that this thing stays with you and becomes part of you. All right. Okay. So please have a fantastic good night rest and a fantastic rest of the week. And I'll see you guys in our next class.
Please, sir, do you made mention of set?
Yes, I said that you guys can go and look up sets.
Yeah. Okay.
Yes,
Okay.
you guys can go and look up sets on your own. All right, so please do have a fantastic good night rest and enjoy the rest of your week. See you guys on Monday. Bye.